Okay, I'm going to do an example problem that deals with Venn diagrams and sets and some conditions on those sets. So each of the following statements about subsets of a set U is false. Draw a Venn diagram to represent the situation being described. In each case, show that the assertion is false by specializing the sets. Okay, so let me just do this by example. Starting with A, and we'll see how many of them I can get in one video and onto one page. Let's see, it says that this statement is false. For all A, B, and C, if A is not a subset of B and B is not a subset of C, then A couldn't be a subset, then A isn't a subset of C. So they're claiming that this is false, and this is an if-then statement. A is not a subset of B. Let's write it out in symbols. And B is not a subset of C. I did this one on the board, I'm quite sure. Then A is not a subset of C. Okay? And the way to prove something like this false is to have a true premise but a false conclusion. So we seek A not being a subset of B, and B not being a subset of C, and A being a subset of C. Okay, so here we have a true premise and a false conclusion. So if we can prove that this situation can exist, then we've proven the statement, the if-then statement, false. Okay, remember, in the truth table for an if-then statement, there's only one row where it's false, and that's where we have the true premise and the false conclusion. So I want A to not be a subset of B, B is not a subset of C, but A is a subset of C. Why don't I start with that one? Let me draw C here and make A a subset of C. Okay, this is what they mean by specializing the sets. Now I've specialized the sets so that A is a subset of C. Now I want to make it so that A is not a subset of B. Okay, that means that A is not completely contained within B. And so I can't have this situation. So I have to have either A is on the outside of B or A and B are overlapping, right? And B is not a subset of C. So B can't be inside C and A can't be inside B. What happens if I just draw B out here? A is not a subset of B and B is not a subset of C. That works. I think there's other ways I can do it. I think I can say that if C is here, A is here, and if B is like this, I think that works also. B is not a subset of C, A is not a subset of B, and A is still a subset. I think there's a few more ways I could do it. C, A, and I think I can make B go on like this. Yeah, that works also. So, yeah, the other possibility is that B moves, so I'm sort of moving B in. I start with B out here and then I move it in part way, but it doesn't overlap A, and I move it in part way and it does overlap A. I can't move B all the way inside of set C because I want B not to be a subset of C. So I think these are the only three possibilities for part A. But there are three distinct Venn diagrams that I can draw that prove this statement false. Okay? Let's move on to part B, and it looks like, so part A is false. Let me move on to part B, and I think I'll need a new page for that. It says for all sets A, B, and C, A union B intersect C is equal to A union B intersect C with the parentheses in the other order. A union B intersect C. Oops. Let me add this one. I'm inserting a page in my video. And I can go to it. A union B, part B. A union B intersect C is equal to A union B intersect C. And On the left side, they put the parentheses on A union B, and here they do it in the other order. In other words, you can't mix unions and intersections without putting the parentheses in. You have to tell which to do first. Okay? I'm going to draw, for the left-hand side, this is the left-hand side, I'm going to draw what I call the complete drum set here of sets A, B, and C. And I'm going to shade in the region A union B intersected with C. A union B is this region, in red, and if I want to intersect that region with C, then I'm going to, let's see, I'll shade it in now. I'll shade it in. If I intersect the red with C, then I'm going to get this shaded region here that I'm showing in green with a little bit of overlap. There's the region, and I'll give myself a little legend. A union B intersected with C. Okay, now on the right hand side, I'm going to do the same thing. Okay, I'm going to draw the complete, the most general situation of sets A, B, and C, and I'm going to go ahead and do B intersect C first. I'll do that in red. B intersected with C is this red region, okay, and then I'm going to union that with A, and I'll color that in with green. So I'm going to take A and I'm going to union that with this thing in red. Okay, and clearly, so I'll fill that in, and clearly, so this on the right hand side in green is A union B intersects C, and clearly these two are not equal. Therefore, this is false. Okay, and I think I'll stop here and do part C in a new video.